Assalamualaikum and hi to Dr. Siti and Dr. Felix. We are from Group 8 and this is our video presentation from our project.
Assalamualaikum, my name is Siti Hajar Binti Raduan. My matrix number is CF190058 and I would like to present about introduction. A slope is an inclined earth surface whether it is formed naturally or artificially made. A slope failure will experience downward movement whether in slowly or rapid condition when the stability condition of the slope cannot be achieved. The earth slope's capability to endure any motion, stability and shear strength are the major keys to ensure there is no chance for slope failure to occur. Next is type of slope failure. First is translational failure. An infinite slope is where there is no border determined and believed to experience the same properties and similar deepness as the slope at the bottom of free surface soil. Second is rotational failure. The upwards and downwards movement of the surface of a failed slope. The slip surface of this failure will cause rotation, resulting in the curve of slope surface and failing until the end of the two of the slope. Next is compound failure. This type of slope failure consists of combination of translational failure and rotational failure. Compound failure happens when the surface of the slip curve at each end, however, still contains a level central point. The surface of the slip can change to flat if a considerable depth from the slope to from a hard soil level. Lastly is wedges failure. This failure occurs if the layers and joints of the soil weaken, resulting in the building of the slope from two unsimilar and incompatible materials. Both finite and infinite slope can experience wedges failure. Issues of slope failure are rainfall, geological features, slope type and steepness, drainage and moisture content, and lastly vegetation cover. Lastly is our case study. Slope failure that occurred at Bukit Antarabangsa, Ampang, Selangor around period of December 2008. There is no sign of any earth motion present in seismic records and had been confirmed by the authorities. Since the area of the event occurred near the abandoned house, the chance that the landslide happens was due to the possible leaking or bursting of old and active pipes, which leads to the build-up of water pressure in the soil pool. The eyewitness said the bungalows that were affected by this event were described as experiencing fluctuating movement. On the condition, the failure debris from the slope swept the building away, which signifies that the failure debris was saturated with water and also the slip plane of the landslide was deep. Lastly, the unsuitable design of drainage for the slope design and also the unsuitable drainage of the slope and the lack of enough maintenance of the drainage together with human error is the main factor. That's all from me. Thank you.
Assalamualaikum and hi, my name is Aina Binti Fadzil. My number matric is CF190045 and I will explain about literature review. So we go to slope stability analysis. There are 4 methods. First is limit equilibrium method. This method is a technique that has been used to analyze slope. There are numerous methods of limit equilibrium that depend on the type of problem, which is either secular or non-secular. The second method is the ordinary method. This is normal method of slices can find the moment equilibrium for a secular slip surface but exclude both the interslice normal and shear force. Third method is bishop method. This method are in the case of a secular shear surfaces. The interslice normal forces are considered but the interslice shear forces are ignored. Last method is Jambu method. This method uses a composite shear surface and may be used to both secular and non-secular failure surfaces. For techniques of slope stability remediation, there are 3 methods. First is geometrical method. This method is easy and low cost. Creepy grass surface can naturally stabilize the slope. This method is low maintenance and can combine with the other method. Second is drainage method. This method increases slope stability while minimizing pore water pressure and soil saturation. It must be maintained in order to increase long-term slope stability. Lastly is retaining structures method. This method is fairly expensive but is very flexible in nature. The strategy is to resist the pressing forces of the soil masses. Landslide remedial works can be classified into 4 categories as we show in our report. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and hi, my name is Syawal Asnawi bin Sukri and my matric number is CF190130. I will explain about the methodology.
technique of slope stability can be divided into three categories. Slope can be stabilized by adding a surface cover, excavating and changing the slope geometry, or adding support structure to reinforce the slope. Slope failure at site location was caused by poor drainage, so we will improve the drainage system by using horizontal drainage system. Horizontal drains are a common solution for stabilizing hillsides. They are installed along a slope and drain in the direction of the slope. The effectiveness of drain is governed by their diameter and spacing. The larger the diameter or the lower the spacing, the greater the increase in slope stability, as well as their location in relation to a potential critical slip zone. Horizontal drains were used as preventive measure to control poor water pressure and to collect water within the slope, thereby improving stability. To construct a horizontal drain, we require to know the materials, the temporary staging, the drilling process, the installation process, and lastly the equipment that we use. As an example, the material used for horizontal drain is 75mm diameter, minimum class of B, PVC pipe with 75mm x 6mm slot at 200mm centers on the upper half of the horizontal pipe, and wrapped with non-woven geotextile. The horizontal drain should be spaced as mentioned in the drawing. The type of drilling machine used shall be dependent on the slope profile, the height, spacing, and the availability of working platform. Temporary staging shall be erected along the slope side so as to enable drilling of the soil by small portable drilling machine, and also as a platform for workers. Temporary staging shall be erected by bracing pipes fastened together by pipe clamps. Having extra diagonal bracing enhance the rigidity of the whole frame and firmness of the ground on which the support stand must be ensured. Generally, minimum 75mm nominal diameter borehole is drilled at the required location with either rotary or rotary percussive drilling machine to the required depth and inclination. Temporary casing are to be used if necessary to stabilize the boreholes. Temporary casing has to be removed after the installation of horizontal drains. The horizontal drain should be spaced at 4 meters center to center or as directed by the SOA. The location of horizontal drain should be determined by the engineer on site if the exact location of groundwater seepage is known. If the location of groundwater seepage area is known, horizontal drain should be added horizontally both sides until there is no water coming out from the last one installed. Soil nailing has the effect of improving slope or excavation stability by increasing normal force on shear plane and thus increasing shear resistance along slip plane in friction soil. The reinforcement is installed horizontally or gently inclined parallel to the direction of tensile strain in soil nailing so that the maximum tensile force is developed. Before we can proceed to the construction, we need to design first our soil nail wall by beginning with the selection of limit state and design approaches. One of the software that we can use to design the snail wall is the Snail Plus software. The initial consideration will include wall layout, soil nail vertical, horizontal spacing, soil nail pattern on wall face, soil nail inclination, soil nail length and distribution, and so on. With all these variables in the mind of the design engineer, the next step is to use simplified charts to preliminarily evaluate the nail length and maximum nail force. There are 12 steps involved in designing the soil nail wall. The soil nail system is required to fulfill the fundamental requirements of stability, serviceability, and durability during construction and throughout its design life. Other issues such as cost and environmental impact are also important design considerations. There are various international codes of practice and design manuals that we can follow to design soil nail according to safety requirements such as is shown in the video.
Next, I, Mohd Fakhrullah, will present about discussion long-term stability for the proposed technique. The first technique is soil nailing. The soil nailing method can be used if suitable soil conditions are met. With the right ground condition, the soil nail can last for a longer period of time. The best ground conditions for soil nailing are such residual soil, weathered rocks, and stiff cohesive soil. However, if proper soil conditions are not found, this method will not work properly. Soil that has high moisture will contribute to stability problem. As a result, the slope does not have enough energy to withstand the downward force and cause failure. The second method is the drainage method. Drains are often used to lower water table elevation or reduce pore pressure. Drains are one of the fastest and cheapest slope stabilization method. This method is also capable to stabilize the soil for a longer period of time if it is applied properly. To make sure the drain can use for a longer time, we must have the proper drainage of surface and subsurface water. Other than that, the material used for constructing the drain at the slope must suitable according to condition of the slope. Next, maintenance and installation for the slope remediation method also plays a role in ensuring the longevity of the slope for it to sustain its stability. Having workers who specialize in the installation of the method, providing a maintenance manual and post-construction inspection of the slope. Monitoring the movement and change in condition is able to ensure that the structure or the slope stabilizer is in good condition. For the conclusion, development in the upstream area will increase the amount of water that flows downstream, contributing to land failure. This finding revealed that the majority of these failures could have been avoided if extra care had been taken and input from engineers with relevant experience in geotechnical engineering had been sought at all stages of project implementation from planning to design, construction and maintenance. The increased media attention has spurred the establishment of rules and regulations by government ministries to guarantee that hillside projects are approved in a timely manner. That's all from me. Thank you.